everyone. I'm Dr. Jagadha, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. The topic for discussion we selected triple integrals in Cartesian form. We are going to discuss about the definition of the formula for which is defined for triple integrals. Based on triple integrals, we are going to solve few problems. A triple integral, which is also known as multiple integral, that is the triple integral from where, what is the basic, the fundamental of getting this triple integral is definite integral. This definite integral is integral a to b f of x dx. That is, it is definite integral which is related to one variable. So the extension of this definite integral is our triple integral. If it is related to one variable, it is definite integral. That's what here it is written, definite integral of a function of single variable. So from single variable to, it is connected to this definite integral to three variables, then it is called triple integral. The triple integral to evaluate the formula is, as it is a triple integral, three integrations are there. This is called innermost integral. This is middle integral. This is the last one is outermost integral. The function, it has the variables x, y, and z. Three variables. The function in terms of written three variables. So the innermost integration, the limits are z1 and z2. That's what here written. The innermost we are going to do with respect to z first integration, because the limits are defined for z from z1 to z2. So z1 equal to some function. It should have some variables or it can have constants. So constants, or if it is a function, then it must be compulsory x and y or alone x. The next one is the middle one. The middle integration is with respect to y we are going to do. The middle integration with respect to y we are going to do, that is from y1 to y2. So the y1, y2, we are going to write y1 equal to, the y1 is a dependent on some function, that is x. X, y, z. Three variables are there for the triple integral. This is for the innermost integral, that is z equal to, we are going to write. So one is completed. The second one, the middle one, we selected this one. So when we are selecting this one, it should be a function of x only. If you are defining this is, it is a function of x and y. The last one is with respect to x. That is for outermost integration with respect to x we are doing. The limits are from x1 to x2. So it is written here, x1 and x2, they are constants. Now, this is the first problem. Evaluate. The inner integration is from 0 to e. The middle integration is from 0 to 2. The outermost integration is from 0 to 1. All are 6 limits. 3 upper limit, 3 lower limits. The 6 limits are constants. If they are constants, which one to be done with respect to x we have to do, or y we have to do, or z we have to do. Anything we can do it. Nothing wrong in it. But suppose the interior integration is a function of variables. That is our variables x, y, z. If it is a function of the interior, middle or outermost limits are defined in terms of these 3 variables, any variable, then we have to be very careful. In this particular problem, we don't have any confusions because the 6 are constants. Very easy problem. Now, we will focus on solution. So the presentation given, so the integration, the equation as it is we have written. So now we can see here the circles are there. This is to increase the understanding level of the triple integrals, how to do. For this animation is done. That is, 3 integrals are there. That's what 3 circles we selected. In this, I'm going to insert our question. Yeah, it is inserted. Now, the 3 integrals, we are here to come out. First this, the pink color, that the innermost integration, it is circled, that to be solved first. Then, after solving, that is with respect to y we are going to do. After solving, we will be getting some result that will be substituted here. Then we will focus on the second, that is a middle integration. With respect to x, we will do it. Then 2 will be completed. That result we will substitute. Finally, with respect to z, we will integrate it. To represent that, this diagram, to increase our concept should be very strong. Understanding level purpose, this diagram which is kept. Now, we are going to focus only the interior one, separate we are doing. Then again a doubt is coming. Why we can't do it keeping there only? We can do it. That is also correct. In this video lecture, keeping there also, we will solve one problem. First now, separate how to do it. Here the innermost, it is written here. Our innermost integration is from 0 to e dy. Yes, it is written here. So now integral dy, it's nothing but y. So here it is written. From 0 to e. The limits from 0 to e. Fine. So in the place of y, we are substituting the upper limit. That is e. This is formula minus. and y place we are substituting the lower limit value, that is 0. So we got it e. So now this innermost integration separate we have taken, we evaluated, and we got the result e. Our next the job is, in this place we are going to substitute this value, and we will be focusing on the middle integration. So this is we completed just now. The answer we got it e. That we will substitute in this place. We substituted. So the next, actually the middle integral, the limits from 0 to 2, it is written here. That is with respect to x we are going to do. So the dx. So if we solve this integration, then two circles, that innermost is will be already be completed. Now if we integrate this, the middle integration, the work also completed. Now this integration, the e we have taken out. That is, to avoid the confusion, just we kept before the integral, and this 0 to 2 it is written as it is dx. We know very well here e is written as it is, and dx integral is x. That's what it is written here. The same 0 to 2, this limits from 0 to 2, it is written. So in the place of x, we are going to substitute, that is e is written as it is. Here x is taking first upper limit value, that is our upper limit is 2. This is formula minus, and x place we are putting the lower limit value. It's nothing but 2e. So now this we completed in the previous slide, we discussed it. We got this is the result. We substituted in this particular place, and here after substituting, then we focused the middle integration. We integrated with respect to x. Yes, here we got the result 2e. Now that's what it is written here. What we got it, the middle integration, the result is 2e, it is mentioned. Now our complete the problem, the question is triple integral. The innermost middle 2 we completed. We have to focus on now our outermost integral. So this job we completed. We got it, our e. And we substituted here. The second one we focused, we got it 2e. Now this complete up to inner and middle, both together we got this. This is the result. So now we are going to substitute this complete. This is nothing but this 2e. It is substituted. The outermost integration is, the limits are from 0 to 1. So just 0 to 1. The outermost integration is with respect to z. So it is written dz. Integration. So now the 2e we can keep it out. 0 to 1 dz. So we can see it here. 2e. dz integral, it's nothing but z 0 to 1. So now the 2e, it is written as it is. Upper limit is 1 and the lower limit is 0. So the upper limit in the place of z we are substituting, we got it 1. So formula minus the lower limit z place we put it, that is 0. So 2e into 1 equal to 2e. So we got it. The complete the problem we did. So the next one is evaluate triple integral. 1, 2, 3, 4, 5, 6. All the 6 limits are constants. If they are constants, here we can first dy or dx, anything we can do it. Before the sum, we did innermost, middle, outermost, separate we did, and the particular places substituted and we did the previous problem. Whereas now, this problem, we will do it in a different way. All are correct. Anyway, we can evaluate the triple integrals if all the limits are constants. Now, the solution is given. The question we wrote it as it is. Since all the limits are constant and the function, that is the integrand, is explicit in x, y and z. Now, if we are noticing here all are constants, suppose here this is given, suppose the innermost is given x plus y. Then the innermost is defined for z, because x, y, z, three variables totally. As we are doing triple integral, in this 2 are given here. That means the innermost integral is a function defined, is a function of x and y. Z is dependent on x and y. If this dependent z, it is written in terms of x and y, that is explicit. That is, the dependent variable is defined in terms of their function. Independent variables, then we will tell, we can use it explicit. Now this integral is written as, according to our problem, as we have all the limits are constants, this particular problem we don't have any problem we are going to face. If you change this with respect to y first, or with respect to x, or with respect to z, anything we can do it. Easy way, as the limits are constants, this 0 to 2, the outermost x, so x dx we put it. The middle one is 1 to 3, that is for dy, it is written. Y related to the variable is y square, that we put it here. So the innermost is 1 to 2, that is dz. So dz related to z is there. This way it is possible if the functions, that is dependent, the variable is expressed in terms of independent variables. If it is possible, then like this we can use it. At one stroke we can easily finish the integration. And the limits also should be constants. Now, this x dx, we know the simple integral formula x power n dx. That is x power n plus 1 by n plus 1. Here our n is 1. So we are substituting in this particular place. So it has become x square by 2. That's what this integration is, x square by 2. The limits are from 0 to 2. The same here, the formula, according to this, our n is 2. So y power 2 plus 1 by 2 plus 1, it's nothing but y cube by 3. So our middle integration, the limits are from 1 to 3. It is kept here. So the third one, according to here, this is the innermost integral. That is from 1 to 2. That is z dz. So z power 1, 1 plus 1 by 1 plus 1, z square by 2 from 1 to 2. So this way also it is very easy way to integrate if the function is in explicit form. Now, this first we are applying the limits. In the place of x we are substituting, we got it 4 by 2. That's what here it is written, 2. So the lower one is 0. So we didn't write it. The middle one is y cube by 3. So the y place we substituted, we got it 3 cube. So 27 by 3, this is formula minus, and y place we put it to 1, we got the lower limit 1 by 3. So this limit substitution also we completed. So the remaining part is this one, that is z square by 2. So the upper one is 2. Substituting the same 4 by 2, we got it 2. This is formula minus for the limits. Z place we are substituting the lower limit 1 by 2. So the solving 2 is written as it is. This 27 minus 1, 26 by 3, and this we are taking. So 4 minus 1 by 2 equal to 3 by 2. It is written here. 3, 3 cancelled, 2, 2 cancelled. We got it 26. So we completed the second problem also. The third problem, very interesting problem. All the concepts of triple integrals in Cartesian form, it is covered in this problem. Because the other two problems we discussed up to now, the limits are constants. But here the limits, if we are noticing the innermost, the limit, totally 3 variables only we have, as it is triple integral. So the innermost is a function of x and y. Automatically, then this is defined for z. So we are going to write z equal to z equal to. Looking at the question, we have to identify. So now x, y, z, innermost it has come for z. So we have to do the integration with respect to z first. But here dx is given. The next one is only x is there. Already we defined a z. So the balance is this one only. The middle one is a function of x. Then which is dependent? We have to write y equal to y equal to. So z, y, the two are defined. The leftover is, the last one is x equal to. This is the easy way we can check the limits. So innermost is, here the dependent is z. So we have to do the integration with respect to z only first. But in the question it is given x is first. We have to modify the question. First we are writing as it is. The next we modified it because this is innermost integration is a function of x and y. So this is, here z is the dependent on x and y. The limits is for z dependent on x and y. That's what it is given in the question. So we have to do compulsory. With respect to z only, we have to do it first. So it is mentioned. The middle one is 1 minus x. So here y is dependent on x. The next we have to focus on, with respect to y, we have to do the integration. The final one is with respect to x. According to the limits, the changes are occurred. So the first, when the problems, when we are solving using this triple integrals, limits first we have to focus. Limits are constant. We won't face any problem. But the limits are defined as a function of variables. Then we have to be very careful. This is a good example for that. Now, how to integrate it to increase our understanding level more? So the three circles are there. In these three circles, we are going to fit our question. Yeah, it is fit. Now, the innermost integration we are going to do first. That is with respect to z, we are going to do it. After doing, what is the result we are going to get after this integration? That will be substituted in this particular place. Inner integration job will be over. After substituting here, then we will focus the second, the middle integral with respect to y. That result will be substituted here. Finally, we will concentrate the outermost integration with respect to x. Simple concept. So now this innermost integration, it is written. We know it. Integral dz, it's nothing but z. The limits are from 0 to x plus y. That's what, from 0 to x plus y. Upper limit, we got it this one. That is, in the place of z we put it. Minus, formula minus. The lower limit is 0. As it is, the lower limit is 0. That's what it is not mentioned. So now the innermost we integrated and we got the result x plus y. Now we will move to middle integration, substituting the result in this place, and we will do the integration with respect to y. Yes, fine. This is the innermost integration. We integrated. Just now we got it x plus y. Now we are going to concentrate this particular place, we are going to substitute this result. We substituted. Yes, this is the middle integration from 0 to 1 minus x dy. That is, with respect to y, we have to do it. X into dy, xy. That is, x dy. We are doing the integration with respect to y. If it is simply dy, we know it is y. X is another variable. We are doing the integration with respect to y. If any other variable, then they are treated as constant. So this particular integration, we can use the word partial integration. That is, x is here treated as constant. Plus y dy, the integration, simple integration, y square dy, our usual integral formula, y power 2 plus 1 by 2 plus 1. Sorry, y power 1 is there, y dy. So y power 1 plus 1 by 1 plus 1. That's what it is, y square by 2. So the limits are from 0 to 1 minus x. It is written here. Now we have to substitute the upper limit in the place of y, because we did the integration with respect to y. So x is written as it is. This y, it is taking the upper limit value 1 minus x. It is written here, substituted, plus here y place we have to substitute 1 minus x. We substituted. This 2 is come as it is. This 2 also it is written as it is. We completed the upper limit. We substituted. This is the result we got it. This is limit formula. This is the lower limit, because two terms are there. Both the terms, y term is there. That's what the lower limit. After substituting in the place of y, we got it here 0. So the next one, simplification. Just this is 0. We neglected it. Remaining as it is written. But here x we have taken inside. X into 1 x. This minus as it is. X into x, x square. So now this innermost integration we solved before the previous slide. That is, this is the result that we substituted, and we focused the middle integration. This is the result we got it for the middle one. That middle one we are going to substitute here. We will focus on the outermost, the integration. Then we will come to the result, the solution of this given problem. So now we substituted here. That is, this is the result. This is over. This is over. The complete, this 2 is here. We put it. The outermost is from 0 to 1. As it is written the integration. The outermost integration is done with respect to x. So it is dx. So now we can see here x minus x square plus 1 minus x the whole square by 2 dx. Now this is x integration, we have to do it. So x dx, it's nothing but x square by 2. It is done. This minus sign, it is written as it is. And x square integral, x square dx, the simple x 2 plus 1 by 2 plus 1. So x cube by 3. This 2 it is written as it is. Only the integral of 1 minus x the whole square dx. Simple way, our formula is integral x power n dx equal to x power n plus 1 by n plus 1. Our n is 2. So 1 minus x power n plus 1, that is 2 plus 1 by 2 plus 1. Again, the inside the x, the coefficient is minus 1. So here 2 plus 1, 3. That is the reason, because of this coefficient, it has minus 1. It is becoming minus 3. So we put it here. So the integration, we completed this one. The next, here as it is, this as it is. Only the simplification we did. This 2 3s are 6. This minus sign, we brought it up. So the 1 minus x, the whole cube, the limits are from 0 to 1. The simple way, the upper limit, the value is 1. In the place of x, we are going to substitute. So we substituted, we got it 1 by 2. This minus sign as it is, and here 1 by 3, here minus, and here 1 we are substituting here. 1 minus 1, it has become 0. That is the reason here 0 it is kept. We completed the upper limit. This is the formula minus. Lower limit we will concentrate. This is x place, we are substituting 0. It is 0. Here also we are substituting, the value is 0. Whereas here, this is limit formula sign. This is problem sign, this one. Here 1 minus 0 we are applying. It is becoming 1. That is the reason 1 by 6. Now here this simplifying, 3 minus 2 by 6, it is 1 by 6. This minus, this minus, this minus put together, it has become plus 1 by 6. Put together 2 by 6. We gave the lowest form 1 by 3, taking 2 as common, cutting. The final result we got it 1 by 3. So the next problem we will focus the triple integral. The function is e power x plus y plus z dz dy dx. The innermost, the integration from 0 to x plus y. The middle integration is 0 to x. Outermost is from 0 to a. So the question we have to do any modifications, any changes are required according to the limits, that we have to focus. Innermost is a function of x and y. If it is a function of x and y, then which is the dependent variable? Totally we have 3 variables, x, y, z. So the innermost is a function of x and y, the leftover is z. So compulsory we have to do the innermost with respect to z only. Fortunately, same it is given dz, so we no need to modify. But before problem, we did the modifications. We did the changes according to the limits, the previous problem. Whereas this problem, it is not required. So the solution given, the question it is written as it is. Now we are going to focus This is x plus y. The innermost is a function of x plus y. So it is written z equal to, that is from z equal to 0 to x plus y. We have to do the integration with respect to z first. The second one is a function of, the middle integration is a function of x. It is defined, that is y is dependent on x. So y equal to x, that is from y equal to 0 to y equal to x. Innermost with respect to z, middle with respect to y. So the outermost is with respect to x from 0 to a according to our question. Now our function is e power x plus y plus z. We know the exponential law, a power m plus n. We can write a power m into a power n. It's a simple exponential laws. Using that, our function, we wrote it in such a way, e power x plus y plus z, it is written e power x into e power y into e power z. So now, three integrals. We will fit our question in this. Now, this innermost, we are going to concentrate. This is the complete function. When we are going to the innermost, we are going to do with respect to z, we are going to do. So the related to z, the term is e power z is there. The remaining e power x in e power y, if we do integration, they are treated as constant. If you want to keep, before one problem we did, partial integration we can tell. Otherwise, we don't want to touch those terms. Like this also we can do it. That is, before one we kept it e power y. The last, the outermost we are going to do with respect to dx. So we wrote it. Here we kept it. So now we are going to focus this innermost integration. Separate, we will write it. So it is written here, e power z, the integration is e power z. The limits are from 0 to x plus y. So the z is going to take the value x plus y. Our upper limit is x plus y. We are going to substitute in the place of z. We substituted e power x plus y. This is our formula sign. Here, the lower limit is 0. E power 0, the value is 1. We completed that, our innermost, the integral, the final result is, for the innermost integration, the final result is e power x plus y minus 1. With this result, we will move towards our middle integration with respect to y. So this is the focusing, the arrow mark which is animated here. It shows that the innermost integration result is e power x plus y minus 1. Now that this result we substituted in this place, we will concentrate now the middle one. The integral is from 0 to x as it is written. This part e power y, it is written as it is. This is nothing but this result, this animated arrow, which shows e power x plus y minus 1, that is substituted in this particular place. and dy. So this is the complete integration for the middle one with respect to y we are going to do it. Before doing the integration, the simplifications where it is possible, that is e power y we are taking inside the bracket, multiplying e power y into e power x plus y. This can be written e power y into e power x into e power y. This we splitted and we wrote it according to that exponential law. A power m plus n can be written as a power m into a power n. Now here y 2 times it is there. That's what e power x is 1 time x plus 2y. This minus sign is written as it is. E power y into 1, it's nothing but e power y dy. Now we are going to do the integration. So just actually so far what we completed regarding this problem up to the previous slide, that is, this is the animated one. This is the interior innermost integration we did. This is the result we got it. And this particular place we substituted and we got this is the result. We will do the integration with respect to y. So here we are applying the partial integration. So y to be done with respect to y, we have to do the integration. Then another variable is treated as constant. So this is e power x into e power 2y. E power x is treated as constant. It is written as it is. Only we did e power 2y only the integration. That is e power 2y dy. It's nothing but e power 2y divided by y coefficient is 2. So the integrated one, it is written here. This is problem sign as it is we copied. E power y, the integration is e power y. The limits from 0 to x, it is written here. We will substitute the limits now. That is, our upper limit is x. The lower limit is 0. In the place of y, we are going to substitute. So if you substitute in the place of y, this is becoming e power 2x. Already here e power x is there. Put together e power 3x. This 2 is as it is. E power 3x by 2. And this minus sign is copied as it is. This minus sign related to the problem. And e power y plus x we substituted. That is our upper limit. It has become e power x. So, upper limit, the work is completed. This is the formula minus. Now, we will focus on this lower limit. In the place of y, we will substitute. So, this particular e power 0, it is becoming 1. So e power x into 1, e power x, this 2 is written as it is. This minus sign is written, problem related minus sign as it is. Here e power 0, the value is 1. So the lower limit value substituting is also completed. So e power 3x by 2 written. Here minus e power x, here minus e power x by 2. So the taking LCM, we got it minus 2 minus 1, minus 3 e power x by 2. And this minus minus put together, it has become plus, and this 1 is written as it is. So now, We focused the interior one. This is the result we got it. That we substituted in this particular place. And we focused the middle integration. That is here. Focused the middle integration. This is the result for the middle integration. Now we have moved to the final step to complete this problem. The solution of the given problem. If we complete the outermost integration, the problem will come to an end. For that, so this is result, this one. Up to here, this is the result. So this result, we are substituting here. The middle integration, we substituted here. So the outermost from 0 to a, we have written here. This e power x is written e power x. This dx is written here, dx. Now, so this is the final step of this problem. So from 0 to a, e power x into this e power 3x by 2 minus 3e power x by 2 plus 1, we have to do the integration with respect to x. Before integrating, where any simplifications it is possible to make the term as single. That is e power x into e power 3x. So x plus 3x, it has become e power 4x. This 2 is written as it is. This minus is written as it is. Next, this 3 power 3 into e power e power x into e power x, it has become e power 2x. This 2 is as it is. So e power x into 1, it is e power x. Now we will concentrate the integration. That is this part. Integral of e power 4x by 2. So it's a very simple integration. This 1 by 2, we can keep it outside. E power 4x integral is e power 4x by 4. That is coefficient of x is 4 divided by 4. 4 2s are 8. So we got it. For this integral is e power 4x by 8. This minus sign is kept as it is. This 3, we didn't do any change as it is. Here already 2 is there. Integral of e power 2x dx integral is e power 2x by coefficient of x is 2. Already here 2 is there. Put together it has become 4. E power x, we know it, the integral is e power x. So now the upper limit is a. The lower limit is 0. So in the place of x, we are substituting the upper limit a. So it has become now e power 4a by 8. This minus sign as it is. 3 into e power here a we are substituting. 3 into e power 2a by 4. This plus is as it is. Here we substituted, it has become e power a. So upper limit, the work regarding a is completed. This is our formula minus for the limits. And the lower limit value is 0. We will substitute here. So the e power 0 is 1. So it has become 1 by 8. This is problem minus sign. E power 0, the value is 1. So 3 by 4. Plus e power 0, it's nothing but 1. We completed the lower limit, the value in the place of x substituting 0, the work is completed. So now simplification. e power 4a by 8, it is written as it is, and minus 3e power 2a by 4 plus e power a. So the upper limit, substituting what we got it is written as it is. This minus sign here as it is. This only the simplifications. 1 minus here 6 plus 8. Taking the LCM, we got it 3 by 8. It is written minus 3 by 8. So we completed this problem. So the next problem is evaluate. The innermost is 0 to yz. The next one is 1 to z. Then 0 to 2. xyz dx dy dz. So it is written, we wrote the equation as it is. Now if you are noticing, the innermost limits depend on y and z. That is, the innermost is a function of y and z. So if they are the function of y and z, so it can be written x equal to 0 and x equal to y z. Then we have to do compulsory with respect to x only integration. So from 0 to yz, the next one 1 to z and 0 to 2. The function is xyz with respect to x first, next to y, the last one is with respect to z. So now, before we discussed the triple integral problems, very easy way to understand, we did separately. That is, the innermost separately we did. We substituted in the particular place. Then separate we concentrated the middle integration. That result we substituted to avoid the confusions we did. Now we don't want that method. Any other way is there. Any method it is possible which will reach the good correct result, mathematically loss if it obeys. Now this way also it is possible to do it. That we will see it. Now the innermost we are going to do with respect to x. So with respect to x, there is only one term is there, that is only x. Other term we are not going to touch. They are treated as anyway constant. Just we rotate y, z, dy, dz. So integral x dx, it's nothing but x square by 2. So the integration is written. The limits are from 0 to yz. So we can see it here. So now x square by 2 from 0 to yz. This is the inner integration limits are given. So in the place of x, we are going to substitute. We substituted. Here, substituting, this 2 we have taken out. This all, it is written as it is. In this place, we are substituting, we are getting y square, z square. First, before that, this step and this, only 1 by 2 it has come out. Remaining all as it is written. The next step, this, everywhere the same changes. Sorry, there is no changes. Only in this particular place changes are there. That is, x is taking the value yz. Here square is there. So y square z square, it is written. Only upper limit is there. Lower limit anyway substituting it will become 0. That is the reason it is not mentioned. The next one, so wherever I am putting the tick, no changes. So where the changes came, only these two we multiplied it. So y square into y cube, z square into z cube, we got it. Now this 1 by 2 here. Now next we are going to do the integration focusing on y, but the term we got it, z cube also it is there. Anyway, it is going to be treated as constant. So if you are going to treat the constant, better we decided before the integral only we can keep it. So we kept it here z cube. So the next, the innermost, this is the innermost completed. The middle one from 1 to z, y cube dy dz. Now this is the 1 by 2. Here from 0 to 2, and this z cube and dz. This we wrote it as it is. Only this place we are going to do the changes. That is y cube dy. We are going to do the integration. Which part, which variable we are doing integration, that only we are considering. Remaining and all as it is we are writing. So now this y cube, that is y cube dy, it's nothing but y power 4 by 4. After integrating we got it. That's what it is written here from 1 to z. So now this 4 and 2 put together 1 by 8. 1, 2. And this where I am putting the tick, just they are written as it is. This y power 4 from 1 to z. This and this, the change only this 4 2s are 8 we have did the changes, these two steps. So the next one is where I am putting the ticks. No changes. From the previous step, they are written as it is. Only we focused in this place. That is, in the place of y, we are going to apply z. So it is becoming z power 4 for the upper limit. This is formula minus. The lower limit is 1. So 1 power 4 is 1. Here, the 3 ticks from the before step, just they have written as it is. Now this z cube into z power 4 put together, that is the powers we added. The bases are same. We can add the powers, exponential law. So z power 7. This minus sign as it is. Z cube into 1. Z cube. Now this we have to do the integration. So this is the last step in the previous slide. Now integral of z power 7 dz. It's nothing but z power 7 plus 1 by 7 plus 1 equal to z power 8 by 8. So it is here. This minus sign as it is. Now z cube dz, it's nothing but 3 plus 1 by 3 plus 1. Simple integration. Z power 4 by 4, the limits are from 0 to 2. They are written. Now 1 by 8. Upper limit is 2. The z place we are substituting, we got it 256 by 8, this minus sign as it is, 2 power 4, 16, this 4 is as it is, minus the lower limit is in the place of z, the value substituting 0, we are going to get 0, that's what it is neglected. So 1 by 8, the simplification 256 by 8, 32, minus as it is 16 by 4, 4. So we got, simplifying this, 28 by 8, we gave the lowest form taking 4 as common. The result is 7 by 2. We will come to a conclusion of this topic, triple integrals in Cartesian form. First, we have taken a problem, the triple integration, the innermost. First we solved it, the result will be substituted, and we will be focusing on middle integration. After solving the middle integration, this particular place substituted, and finally concentrating on outermost integration. The similar way, one more problem also it is done, that is inner, middle and outermost. Here, which variables? Initially the innermost, we did the integration with respect to z. So x and y variables, they are going to treat it as a constant. That's what they are written in before the integral, and we did this problem in a different way. And the problem here, the question it is given with respect to x to be done first. Next we have to do the middle one for y. The outermost it should be done for z. There is a question which is given to us, but we modified the question according to the limits, because the limits, the innermost is a function of x and y. So innermost, the limit for z. So we changed the question, and dz, dy, dx we did, we completed. So the next problem is, we focused the triple integrals, x, y square z, dz, dy, dx. Here all we are focusing the limits. All the 6 limits are constants. If they are constants, we have the liberty to do with respect to x first, or y, or first z, or first. We can do it. That is also we focused it. And the innermost, this is the method we used it. Separate. If it is triple integral also, we make it as a single integrals in the particular places substituting. Particular places substituting, we did the integration. That is the one of the way. 1, 2, 3. 3 problems we did. This is a different way we handled it. The final problem, there we didn't do separate and substituting, keeping their only integrations we did. So we focused nearly 5 problems in this video lecture in a different ways. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.